Afternoon, madam.
Good afternoon, my everyone. First semester, Unit 3, Random Variable. Random variable. So first I'll explain what's the definition of random variable. Okay, random variable is nothing but a real number which is connected to the outcomes of random experiment. Outcomes of random experiment. So random variable is a real number which is connected with the outcomes of a random experiment. So this definition I'll explain with the help of some example. So in tossing of a coin experiment, in two tosses of a coin, when you toss a coin 2 times, what are the outcomes you have? HH, HT, TH, TT. So if I take X as number of heads, X as number of heads. So what is the value of X then? X counts number of heads. So how many heads you have here? 2 heads. How many heads here? 1. How many heads here? 1 here? No heads, which is nothing but 0 heads. So what are these 2, 1, 1, 0 All these are nothing but here real numbers. 0, 1 and 2 are nothing but real numbers. And these real numbers are connected to what outcomes of a random experiment. So what is now random variable? Random variable is a real number which is connected with the outcomes of a random experiment. So we call X as random variable. Okay. Now in this random variable, you have 2 types of random variables. First one, discrete random variable, and second one, continuous random variable. So in this, we have 2 random variables, discrete random variable and continuous random variable. You can expect this question for 4 marks for short answer. So first I'll explain about discrete random variable. Discrete random variable. So discrete random variable means a random variable X which takes countable number of values, okay, which takes countable number of values. Then we call it as discrete random variable. Discrete random variable means which takes countable number, all possible values, countable number of values. We call it as discrete random variable. Example, you can say number of students joined in Pragati College MSCS first year, which is nothing but countable number. So number of students joined. Next one, you can say number of accidents occur in Hyderabad per 1 day. Number of accidents which you can count it. Number of accidents. All the things which are countable will come under your discrete random variable. Number of students in a class, or we can say number of CA students passed in 2023. We can call it as a countable number. Number of accidents, number of telephone calls, all those things which you can count it, we call it as discrete random variable. Now under discrete random variable, I'll go for probability mass function. So what is the definition of probability mass function? So let X takes the values X1, X2, so on, Xn. Countable number of values, and the corresponding probabilities are P1, P2, so on, Pn. These are the corresponding probabilities. X values are X1, X2, Xn, distinct values, and probabilities are P1, P2, so on, Pn. Function P of X is called probability mass function if it satisfies 2 conditions. First one, probability should always be greater than or equal to 0 for all the values of X, since probability cannot be negative. And second one, total probability should be equal to 1. If these 2 conditions are satisfied, then we say the function P of X as probability mass function. So the important definition here it is probability mass function. So what is probability mass function? If it P of X satisfies 2 conditions, P of X greater than or equal to 0 and total probability equal to 1. If these 2 conditions are satisfied, we call P of X as probability mass function. Next, probability distribution function. Probability distribution function. So probability distribution function is nothing but the set of values containing xi values and p of xi values. Then this set we call it as probability distribution function. That means all x values and the corresponding probabilities put together. Then we call this set as probability distribution function. Now coming to continuous random variable. We have discussed about the discrete random variable. Now coming to continuous random variable, a random variable x is called continuous if it takes all possible values between two limits. For example, I take 1, 2. So what are the values you have in between 1 and 2? It's not 1 and 2. What are the values which lie between 1 and 2? After 1, what's the next value? 1.000001 till 1.999999, and next comes the number 2. So in between 1 and 2, how many values you have? Uncountably infinite number of values are there. So if x takes all uncountably infinite number of values, then we call x as continuous random variable. Discrete means what Just countable numbers. 1, 2, 3, 4. Only countable number of values. Can you count these values? 1.001, you can't count it. So uncountably infinite number of values which lie between two numbers 1 and 2, we call it as continuous random variable. Now coming to the example, that means all decimal points will come under example. That is height of the students. You can call it as weight of the students. Height, weight, rainfall recording, and temperature. All the things which comes under decimal points, we call it as continuous limits. Examples are height, weight, rainfall recordings, and temperature of the human beings or the weather. All these are coming here continuous random variable. So for continuous random variable, you have probability density function. For discrete random variable, you have probability mass function. For continuous random variable, you will be having probability density function. So probability density function is defined between two values a and b. Then it can be written as P of a less than or equal to x less than or equal to b. So x is taking what values between a and b, and this can be written as integral. Discrete case we use summation symbol, and in continuous case we use integral. Integral, what are the limits? A to b, the function f of x dx. So the function f of x is called probability density function if it satisfies two conditions. First condition, you have learned for your discrete case. What is that? Probability of x greater than or equal to 0, total probability equal to 1. Here, the same condition here also, but the thing is, in place of summation, we use integral. So in place of p of x, we use f of x. So what is the first condition? F of x greater than or equal to 0 for all x. And second condition, total probability is 1. Integral f of x dx equal to 1. Same conditions for discrete and continuous. You can observe it. There you have your p of x, here you have your f of x. There you have summation symbol, and here you have your integral symbol. So if these two conditions are satisfied, then we call f of x as probability density function. Okay, next. So based on your continuous discrete random variable, we have some problems. We'll do that problems. Solve the problems first corresponding to discrete case. Before going to the problems, you should learn your formulas under this random variable chapter. And all this formulae already I've studied in your intermediate. So mean. So what is the formula for mean? Summation x into p of x. I think you can remember. What is the formula for variance? Summation x square into P of x minus mean whole square. I think you can remember these formulas. Okay. So this is under discrete case formulas. Mean is x into P of x and variance is x square into P of x minus mean whole square. Okay. And the same formulas if you want to write for continuous case, this is for discrete case. Now for continuous case, you have same formulas, but the thing is in place of summation you get integral over x into, in place of P of x you should write the density function f of x dx, and for variance formula is integral over x square, in place of P of x you should write f of x dx minus mean whole square. So this is a formula for your variance.